right, here's the practice test for inequalities and absolute value inequalities, graphing inequalities, all that good stuff. It's a 10-question test. Here we go. Okay, we're going to solve and graph this for x. So these aren't equations. Equations imply equal to. So this is an inequality. So it's because it's not equal to exactly. Now some of them on the page in this are equal to as well, like that one is less than or equal to. So we don't always have to be equal to something. We can be less than that. Depends upon different situations in the real world. So here we go. Subtract 9 on each side. And we get negative 2x is less than negative 5. Then you have to divide each side. So we're going to divide each side by negative 2. And we get x is greater than, because when you divide by negative, you just switch the direction of the inequality, 5 over 2, which is the same thing as 2 1/2, 2 1/2, however you want to slice it or dice it. So we're going to put a 0 here, and I'm going to count by 2 1/2. So look what I did there. I counted by 2 1/2. So I'm going to over 2 1/2, and it's it's greater than, but it's not touching the 2 1/2. So I put an open circle and shade to the right, because that's where the greater, bigger numbers are for x. This one here is absolute value. Absolute value is the distance from 0. So this is saying the distance is less than 11, but we don't know if it's positive 11 or negative 11. Excuse me. So we have to write out two equations for this. We get 7x plus 3 is less than 11, and then 7x plus 3 is negative 11, right? So when we put the negative there, we swap the direction of the inequality. So we're going to solve each of these, subtract over the 3, get 7x is less than 8, divide by 7, and we get x is less than 8/7. And then subtract 3, 7x is greater than negative 14, and divide by 7, x is greater than negative 2. So we don't have to switch the direction of the inequality on these, except for when we change the sign here. But just dividing by 7 doesn't change the direction of the inequality, but dividing by negative 2 does. It's when you divide by the negative, you have to switch it. So here's 0. I'm going to go over 1, 2, and that would be negative 2, open circle. And this would be 1, and then a little bit bigger would be negative 7, negative 8, or positive 8/7, positive 8/7, sorry. And we are less than this one and bigger than this one, which means we're shaded in between, or less than 1 and greater than the other one. So this is an and situation when you're trapped between two numbers like this. So you can write it this way: negative 2 is less than x, which is less than 8/7. So that's actually the proper way to write this, or you could write the word and in between. So this is an and situation instead of an or. Or would be on the outsides, like the oars of a boat. Alright, so now this one is like 3 parts. There's a left side of the equation, a middle side of the equation, and a right side of the equation. So what we do to one side, we do to the other 2 sides, right? So it's 3 sides. Negative 8 is less than 2x, which is less than 2. Divide everything by 2. And you get negative 4 is less than x, which is less than 1. Okay, I didn't ask for this one to be graphed, so I just left it that way. The next one here, again, the distance is 2, so you got to make 2 equations, because we don't know if 4 minus 6x is equal to 2, or 4 minus 6x is equal to negative 2. We would switch the direction, but switching the direction of an equal sign is still an equal sign. Minus 4 minus 4, we get negative 6x is equal to negative 2. Divide by negative 6, we get x is 1/3. And then subtract 4, so we get negative 6x is equal to negative 6. Divide by negative 6, and x is equal to 1. Okay, next page. Describe the translation. So this is the whole H and K business. So it's f of x is equal to a x minus h plus k. So since this matches, a is 1, so it's just the same. It doesn't move from the original. But this is 2. This 2 means h because this matches, so the h is 2. So that's 2 spaces to the right. And then the k matches, so it's up 4. Now it's really weird when you see this minus there, you think left, but that's not true. It's because the fact that it's minus 2, h is a positive 2, because see how the x matches with x, the negative matches with the negative, and the 2 matches with the h. So h is 2, it's a positive 2 is h. When it's plus 2, then it's a double negative, you don't see it. Okay, so now we have to do left 4. Well, we're going to do that right now. So left 4 would be x plus 4. So there's a double negative you're not seeing there, and then down 3. So really what's happening here is it's x minus a negative 4 minus 3. So the double negative is positive, but see the h is negative, so it's left to the 4. Okay. Now I've helped you out here. You can see that it's shifted 1 and shifted 1, but I've also put points here to help you as well. So if you put 1 in here, 1 minus 1 is 0, and 0 times 2 would be 0 and then 1. So it goes through 1, 1. So that makes sense because it's right 1 and up 1. Remember, that means right 1 and up 1. Well, that's the vertex, is 1, 1. Okay, and this slope here is 2, so I would go up 2 over 1, up 2 over 1. Well, that's at the point 3. Well, let's see if that 3 matches with 5. So if I put 3 in here, so you see that's over 3, up 5, and that's the slope of 2, and that's the vertex right there, and it's going to go this way as well. So if I put in 3, that would be 3 minus 1, which is 2. 2 times 2 is 4, and then plus 1 is 5. So yeah, it matches. So this is 5, and then because of symmetry, that's going to be 5 as well. Well, let's see if that matches with the slope of 2. So it's over 1, up 5, and then 1, 2, yep, right there. So it's a slope of negative 2 on one of the arms and a slope of positive 2 on the other arm of the V. And there it is. Okay, now this one here is solve for y and make it for your convenience, starting at negative 2 on the y-axis and a slope of 3 over 1. So we go up 3 over 1, up 3, 1, 2, 3 over 1. It's a dashed line. No, it's a solid line. I could put more points if I wanted to. And it says y is greater than, so I want the big y values. So the big y values are going to exist up here. And that means that every single point in this shaded area makes this true. So it's not just this picture, it's like all these points, like 0, 0, 0, 0 would work in here and make it true. Negative 10, up 10, negative 10, up 10. This point, if you put it in here, it would make this sentence true. If y was 10, and then x was negative 10, that'd be negative 30 minus 2. Yeah, that's negative 10 is going to be greater than that. So yeah, this point makes it true. Okay, now we're going to make a V, and we're going to shade below the V. This V got slid up 3 spaces, so 1, 2, 3. And it's a V, it's a dashed V. Oops. Well, my dash V doesn't look very dashed, does it? There. I think I made a dash and I drew a line over it. Anyway, it's a dash V, y is less than. So I'm going to make it out here a little bit further. So it's shading below, because y is less than. The low y values are down here. And finally, the last one, we're going to make a shape from geometry. So we have a horizontal line at 1, 2, 3. No, vertical line at 1, 2, 3. What am I saying? So a vertical line at 3. A horizontal line at negative 2. And a diagonal line starting at 1, the slope of 1. So now we have to be greater than the y, because it says y is greater than. We have to be less than the x, which is this way. And it says y is less than the diagonal line. So we got to be below the diagonal line. So this is our shape right here. So we made a right triangle. Yeah, yes. And that is the practice test.